In the previous video, we looked at what a researcher would have to do to figure out whether two variables correlate. In other words, is there a correlation between X and Y? In our case, in that previous example, we looked at the correlation between destination image and destination risk, and then we looked at the correlation between destination experience and revisit intention. So the problem is, well, not the problem, but the challenge with looking at a correlation is you can't figure out which one is the starting point. So in other words, you can't identify one as X and one as Y in our X and Y allegory. So in other words, we don't know whether, for instance, destination experience impacts revisit intention, or does revisit intention impact destination experience? Or does destination image affect risk perception, or does perceived risk affect our image of the destination? We can't tell that from correlation analysis. Fortunately, we can tell that in a regression. So I'm going to give two video tutorials here in our video series. We're going to look at a simple linear regression and a multiple linear regression. So the difference between the two is simple. In a simple linear regression, you have one independent variable. So an independent variable, also known as an exogenous variable, is the predictor variable. In other words, it's the thing that figures out what effect it has on the other thing. So when it rains, the sidewalk is wet. The rain is the predictor of the sidewalk being wet, right? So you could say rain in that example is the exogenous variable or the independent variable, and the wet sidewalk is the dependent variable or endogenous variable. In other words, the wet sidewalk is wet because it rained. It didn't rain because the sidewalk is wet, so we know that there's a one direction that those variables take, okay? So we want to figure that out here. So we'll go back to our case study. What if, for instance, we wanted to know what was the relationship between tourist satisfaction and revisit intention? In other words, was how satisfied that tourist was at the destination an impact on whether they're likely to revisit in the future? And so say that is our assumption. And then we build up our hypotheses as our null hypothesis. There is no linear relationship between tourist satisfaction and revisit intention. And our alternate hypothesis is there is a linear relationship between tourist satisfaction and revisit intention. So let's run the analysis. So the first thing I want to do is show you what that would look like if we did a bivariate correlation. So we'll reset our box here, and we'll take our two variables, satisfaction and revisit intention. Remember, it doesn't let us choose X or Y where they are. Is this independent? Is this independent? It doesn't let us choose, right? So if we hit OK on that, and we look at our table that's output, all this tells us is that there's a correlation between satisfaction and revisit intention. With a less than 0.001 significance level, we are moderately correlated. Okay? But what if you want to know, does one impact on the other? Is there a linear relationship? To do that, you go Analyze, Regression, and choose Linear. So here we have a totally different looking window. Here you can actually specify your dependent and independent variables. So if you remember, the dependent variable is the variable that is the effect. So we have a cause and effect. So our effect here is revisit intention. We want to know what is the effect on revisit intention of, and here's where we specify the independent variable. So we're going to choose tourist satisfaction as a determinant of revisit intention. Okay, it's important that you don't mix these up. Unlike a correlation where it doesn't matter, here it's important that your endogenous variable is indicated here and your exogenous variable is indicated here. Okay, you want to make sure you use the enter method. There's different types of regressions that can be done. Enter is the most popular. We're going to click on statistics, and we will make sure that our confidence interval of 95% is selected. And we will also make sure that our estimates and our model fit are selected. And then hit continue. Next, we'll go into plots. This is basically the scatter plot that we saw for the correlations, but here it will tell us the linear regression. In other words, the linear relationship between the two variables. So in the Y box, you're going to put the Z RESID, and in the X box, you're going to put the Z PRED, and then you will hit, or actually, yeah, let's do that way, and then we'll hit continue, and then everything else we'll keep it the same and hit OK. So here we have our outputs. So first of all, just look at each one. We have the variables entered, our model summary, an ANOVA, coefficients, the residual statistics, and the revisit intention scatter plot. Okay. I'm just going to check one thing here. Yeah, perfect. Okay, sorry about that. Okay, so here we are in our output. So in the output, we're going to confirm a few things. So first of all, make sure that we entered the correct variable. So we do want to know the impact of tourist satisfaction on revisit intention using the enter method. Here we have the model summary. So the model summary reports what's called the R value and the R squared, adjusted R squared, and the standard error of the estimate. So if you recall from the correlation, a correlation uses an R. It's a coefficient of correlation, in other words. R squared is what we call the coefficient of determination. So in other words, it is how much of the independent variable determines or predicts the variance of the dependent variable. And that number will give us essentially our relationship, our linear relationship between the two variables. So here we have an R square of 0.406. You'll notice the adjusted R square of 0.403. The difference between the two is simply when you have only one independent variable, you'll use your R squared value. And when you have multiple independent variables, you will report the adjusted R squared. So here, because we only have one independent variable, tourist satisfaction, we're going to report the R squared value. So the R squared value in this case is 0.406, and that is considered moderately moderately related. In other words, there's a moderate relationship between tourist satisfaction and revisit intention. However, you'll notice that there's no significance level reported in the model summary box. So that's why we come down to the ANOVA. The ANOVA, if you recall, is an analysis of variance, and analysis of variance tells us if there's differences between means, right? And so because we're looking at the difference between the mean scores of the Likert scale responses, this will essentially say they are significantly different, right? And this will tell us what the relationship is between those different variables. So we'll report here the sum of squares. The regression is what we're doing. The sum of squares of 129.153 with 1 degree of freedom, a mean square of 129.153, same as the sum because we only have one independent variable, and an F score of 128.645 with a significance of less than 0.001. So this significance level is below 0.05, so we can say that there is a significant difference between tourist satisfaction and revisit intention, and that in our model, we will reject the null hypothesis, and we will conclude that there is a linear relationship between tourist satisfaction and revisit intention with an R squared of 0.406 and a point less than 0.001 significance level. Okay. One thing you can do to just confirm is to look down at your coefficients table. So the coefficients tell you the major differences or major understandardized or standardized coefficients of your variables. And of all the things reported here, one thing I like to check is just to make sure that the where is it? The significance level is less than 0.001, and that our beta value reported here for tourist satisfaction of 0.637 matches the R value of our model summary. And the reason we do that is just to confirm that there is a correlation between the two variables. Okay, but to do the linear regression, to report it, you'll report the significance level, your F statistic, and the R squared value from the model summary. All right, coming down to the chart, this is a regression of the standardized residual versus the predicted value, and you tend to see these correlate in tandem with one another. So this is just another way to visually confirm that there does appear to be a positive correlation between the two variables, although admittedly it's not a very neat positive correlation. So it is somewhere between weak and moderate is the relationship between the two.